Friends, good afternoon and welcome back to the summit for the post-lunch session. We have heard an excellent keynote presentation from Dr. Gregory Watson this morning, followed by some very interesting and informative case study presentations from BHEL, Dynamatic Goldland Aerospace, Adler Medic Equip, and Hero Motor Corp in the morning. We will now commence the first presentation this afternoon, which will be from Mahindra & Mahindra Automotive Division in Mumbai. Rarely do companies approach their production demands by holistic thinking. In this case study, Mahindra & Mahindra describe how they achieved a doubling of core production in the foundry while also increasing crankcase output by 50% and reduce environmental damage. Theirs is a solution through process optimization, automation, and energy reduction, which is a fascinating case study. Let's hear it now from Mr. Amar Patil, Mahindra & Mahindra, to know more.
A very good afternoon and warm welcome to one and all present over here. I am Amar Patil from Mahindra & Mahindra. Take this opportunity to thank respected dignitaries, IMTMA, National Productivity Summit, for giving us an opportunity to present a case study on foundry productivity, profit and sustainability improvements through innovative yet frugal solution in core making area. A brief about Mahindra & Mahindra Group. It's a $19 billion group employed 250,000 people with presence in 100 plus countries. About Kanduli plant of Mahindra Group. It's the first plant of Mahindra. It is called mother plant also, vertically integrated, having vehicle manufacturing facility along with various aggregates including foundry product unit. Our theme is from foundry product unit, close to 50 years young foundry, most senior foundry by age in India. We manufacture complex casting like cylinder head, cylinder blocks. We are single source for most of the components, doing export to developed countries like USA and Mitsubishi Engine, Japan. Let's understand the salient features of our project. The problem was there were various limitations to meet BS6 crankcase demand during transition. On challenges front, how we challenge globally available solution which would have costed 20 crores and adopted innovative and frugal indigenous solution within just 3 crores. That too delivering all 3 P's, people, planet and profit, which gave us a payback less than 1 year. So let's understand about our project, a power of indigenous solution, in more details. The slide depicts the linkage of our project theme with our company's vision, policy, deployment towards KMI, KPI and KI. A SWOT analysis made us realize to work on 3 priorities to retain competitive in the market. So 3 priorities were high natural resource optimization, cost competitiveness and capacity creation of crankcase castings. Now let's understand the first concern of high natural resource consumption. This is electrical and thermal energy profile of Kanduli plant. Foundry unit is consuming highest quantity of electric energy among all other units, which is around 34%, 1314 units per equivalent vehicle, and second largest in thermal energy after heat treatment, which is around 19%, 0.178 m kilocalories per ton. We converted our electrical and thermal energy into CO2 generation, which is around 12,000 plus ton per year. We did detailed process mapping of our foundry process and understood that CO2 generation in melting and pouring area is highest due to electrical energy, and in core room area it is the second highest due to thermal energy. A CFT is already working in melting area, so we targeted core making as a focus area in our project. Now coming to the second priority area, which is high casting manufacturing cost. We analyzed our cost under different heads and found that raw material followed by energy and labor costs are highest among all costs. Hence need an immediate attention. Raw material in melting area is commodity driven, hence we focus on core making areas. Similarly, for energy, we found core making being second largest after melting. Melting already one CFT is working on energy optimization, and labor cost also we saw in core making area is highest. So we decided the priority based on this pie chart. Now let's understand the third priority area, which is capacity limitation of crankcase casting. We can see over here, Foundry BS6 crankcase manufacturing capacity was 6,500 numbers per month, which was catering to 30% of Mahindra and Mahindra share of business among all other suppliers. There were many other suppliers for particular crankcase casting. Meantime, one of the supplier has got rationalized on account of strategically non-performance, which gave Mahindra and Mahindra Foundry an opportunity to invert 2,000 numbers more casting per month. At Mahindra, our policy is very fair and transparent. Most competitive vendor will get good business irrespective of whether he is M&M or non-M&M. So it is imperative for us to remain cost competitive on all the time. We have to be on top always. Cost of M&M produced casting is lower compared to other suppliers, which can be seen here through index value. If I consider index value of Mahindra as 1, then other suppliers are like their cost is higher by 19% to around 27%. We did Yamazuki analysis, process mapping, and identified the capacity bottleneck is in core making area, where the gap is around 2,000 numbers per month. Now let's understand what core is. Cores are made up from high abrasive silica sand for casting manufacturing process to form internal profile and cavities inside the casting. Existing process is a combination of shell and core box process, where in shell process is an exothermic process, hence needs a heat which is around 300 degrees centigrade. There are 7 types of different cores are required to produce on one crankcase castings, and all these cores are made up of sand with necessary binders and additives, and they are non-reusable. Once we produce the cores, once we produce the casting, the cores will convert into the dead sand. These are 7 types of cores are produced on 4 different machines. We can see over here. Cores are assembled to produce every single crankcase casting. Production capacity with all machines put together was 260 numbers per day with 18 people to manufacturing them. You can have a look at one example of how one machine is producing only 2 cores with shell process. Similarly, there are 4 different machines producing 7 types of different cores. We did Viva analysis against all 3 priorities and found that process is a root cause. So we decided to challenge the process itself. Idea triggered to explore green manufacturing process. We did benchmarking study to understand the non-exothermic process at various best foundries in India as well as abroad. There was an option readily available used globally across industries. However, we found that capex of those available option is very high, which is close to 20 crores with payback period more than 5 years. We also validated it through life cycle cost, which includes capex, revenue as well as discounting factor. And number of machines required were also 2 numbers with robotic cell having total space required is around 2,000 square feet. This was not which we were intending to. Our aspiration was to develop fully indigenized and frugal concept meeting all the requirements to remain competitive. What next? There was an option. So we have decided to develop an indigenized machine with frugal concept that should be a lesser cost, should have a payback less than 1 year, which should give all the global solution on our machine. and which should accommodate in lesser space. That was the challenge we took at our end. To realize our aspiration, we had 4 further challenges: layout space constraint, sand capacity limitations, manual core unloading, and we wanted to integrate Industry 4.0, which is in line with global solution, that is visualization and data analytics. Let's understand our space constraint challenge first. This is our total foundry layout. Let me tell you that the installed capacity of our foundry was 6,000 ton per year when it was commissioned in the year 1972, which has gradually increased to 18,000 ton per year over a period of time with various improvements. This statistic shows our M&M foundry is best space utilization per ton among all Indian foundries and second best space utilization considering global foundries in abroad. The foundries are having high degree of automation as well as vertical layouts. They can afford it because they get premium price from their customer, which we cannot afford. I am reiterating our existing core manufacturing facility with 4 machines for our BS4 crankcase, which we were doing, and global solution available across industries, having high capex with space required also is 1,750 square feet and minimum 2 machines. So our challenge was limited space as well as high capex. So we decided to go with indigenized single machine producing all 7 cores which can fit on our layout. So our challenge in front of us was no space, how to accommodate a single machine within given layout. You can see over here how that compact our layout is. So this frugal solution we wanted to develop, but the biggest size machine was available in India was producing maximum 4 numbers of barrel cores together, and balance 2 end cores and slab cores requires another machine. First idea click was to get slab core split into the 4 parts and merge with the barrel core, so by which we got rid of 1 slab core. Still, front and rear cores were requiring second machine. We can see over here. We tried to fit 2 end cores also in same core box. However, there was no space to accommodate 2 end cores. Then what to do next? We challenged the dimension of the machine and decided to work towards core box and sand magazine. We studied the sand magazine flow analysis with respect to core box and accordingly modified our sand magazine along with in line with the core box, and modification done on sand magazine as well as amine gassing hood, and we have extended that magazine as well as amine hood by 100 and 150 mm further. We also explored challenging the other parts of the machine and done the necessary modifications accordingly. With this, we could accommodate 2 end cores in a single core box. Now you can see over here all 4 core boxes can produce on a single machine. It is a patented design with innovative and frugal indigenized approach, realizing Make in India aspiration, vocal for local. I can proudly say that first machine which can produce all 7 cores together in a single cycle. But that was not an end. Though our new machine floor space was optimized to 960 square feet compared with the global machine of around 1750 square feet, but still we had a challenge on how to accommodate 960 square feet itself machine in our existing lot where we had no space at all. As you can see over here, we tried to place the machine towards the south by rearranging the machine, but it was blocking the entire aisle as well as fouling with the existing factory roof, which is almost 3.5 story building. And input raw material supply was also far away from the machine. So that option was ruled out. So what to do next? Next option was to locate at north side. Again, we tried to relocate some machines, reorganize the various work stages. Still, it was not getting accommodated, we had many challenges. You can see over here, we have reorganized the stages, optimized the stages, but still we had an issue that machine was unable to accommodate because it was still falling on the roof as well as blocking the eye. We did overcome that constraint by optimizing the headroom size, shifted the machine towards the space available, and also took the machine below the ground level of about 1 meter and accommodated perfectly as per specified requirement. Thereby we got rid of layout space constraint. So our next challenge was sand capacity limitation. We can see over here our existing process of tedious manual silica sand transfer as well as mixing with various additives and discharge it into the respective machine hopper. The capacity was only 1 ton against the requirement of 3.9 ton. The gap was 2.9 ton per hour. That we challenged by introducing a fully automated pneumatic sand supply unit concept. You can see in this animation all necessary additives and discharge to the machine getting mixed automatically. It has been transferred to the respective machine and it is discharging to the machine without man. So by this we got rid of this constraint and created a capacity to 5 ton per hour, again the requirement of 3.9 ton per hour. Thereby we got rid of sand capacity limitation also. Now let's understand our third challenge of manual core unloading. This calls for high fatigue to operator. Once you can see over here that operator needs to lift the core of 80 kg 168 times in a shift. So it was very high fatiguous operation, and it was ergonomically also we did analyze and found it is a yellow stage under SSCS simplified safety ergonomic sheet analysis, which we are following as a methodology for identifying the ergonomically yellow as well as red stages. Solution available globally is to use robot for core takeout from the machine, which would have otherwise costed unnecessarily 120 lakhs. We opted a indigenized frugal solution of flexible core unloader, which has costed us only 40,000 against globally available option of 120 lakhs. It is fulfilling our purpose of taking the core out from the machine. So our next challenge was how to incorporate data analytics and digitalization on indigenized machine. The fourth challenge, as we seen, how we will incorporate Industry 4.0, especially data analytics and digitalization like global solution. We Indians are not behind. Our Mahindra team, along with equipment manufacturer, have incorporated all production related and quality related parameters, core box like monitoring as well as PM, TPM, CBM monitoring, which we are monitoring under TPM since our foundry is TPM consistency state certified by JIPM, Japanese Institute of Plant Maintenance. Thereby, we got rid of all the challenges. Now, finally to summarize, we have replaced that globally available solution with our own indigenized machine with frugal concept, which is a costing less than 280 lakhs, giving a payback only 0.75 years, is lesser than 1 year. We have also ensured our machine has incorporated all the feature of the best solution available globally across, and we have challenged the space constraint and we manufactured the machine which can accommodate within given space 960 square feet against the solution available was around 2000 square feet. Our full view of our indigenous developed machine, a machine size equal to almost 3.5 story building, incorporating every single parameter in realizing our objectives. a true example of vocal for local. You can see over here the height of the machine, which is almost touching to our roof, which is 10 meter of high, 3.5 story building, close to 3.5 story building, all 7 cores in single die, entire automation for sand transfer system, flexible core unloader with frugal approach, and entire industry 4.0 parameters of data analytics and digitalization has got incorporated in our machine. You can see an operation of this machine producing 7 cores in a single cycle through an animation. The gassing hood, no heating is required. In ambient, we can produce all 7 cores. Cores are taken out with a simple mechanism of flexible core unloader. We can have a look at before and after process for better understanding. Earlier, 1 core shooter is producing 2 cores with exothermic process, requires heating and lot of fatigue, manual sand transfer. You can see over here. Operator is taking out the core manually. 2 cores per machine, requires more number of machine. However, in after case, 1 machine is producing all 7 cores easily. Results: capacity of crankcase production has increased to 8,700 numbers from earlier 6,500 numbers. We have created 2,200 numbers more crankcases than requirement of 2,000 numbers. Share of business for Mahindra & Mahindra has been increased from earlier 30% to now 40% with seamless migration from BS4 to BS6. You can see the results under electrical thermal energy as well as CO2 emission. Electrical energy reduced by 42 kWh units per equivalent vehicle. Thermal energy also in millions kilocalories per ton reduced by 34%. CO2 emission in core making department has been reduced by 48%. Result under production quality cost safety parameters are: production increased by 34%, manpower reduced by 50%, and productivity improved by 169%. Quality improvement, we achieved 25%. Cost of product reduced by 7%, further made us to stand more competitive in the market. And no ergonomic stage on this machine. The benefits: machine OE of this indigenous machine is 86%. Cost of poor quality has been reduced by 5.2 lakhs. Total resource cost saving achieved is 362 lakhs per annum. We have certified this saving from our account department. Under environmental front, CO2 emission reduced by 581 tons per year, which is equivalent to electrifying 1,000 homes per year and heating the gas for 1,200 homes per year. We have ensured standardization to retain or sustain the benefits, and horizontal deployment we shared with our own MICROMATIC Group foundries as well as other foundries also. This is our project timeline. It took 12 months from start of the project to realizing the results and validating the results. We have applied for a patent. We can see over here patent number for this innovative project. We have got an award for best energy efficient project at sector level and best sustainability project at plant level. Proudly I can say that by Indian Institute of Foundrymen has awarded us a best foundry in India, as well as we got an award as a best green foundry in India at national level and best quality performance in India at national level too. Some of the compliments received from our senior leadership team. Our future plan is to work on port core drilling and deepening area. Port cores are such, they are most critical in terms of fuel efficiency of the vehicle as well as performance of the engine. We'll be working to improve our port core manufacturing process further with the help of cobot. Thank you very much for patient listening.
Good afternoon, Mr. Amar Patil. Kudos to
Yeah, good afternoon,
Mahindra
sir.
and the Mahindra team for this wonderful project related to Foundry, and especially with a lot of improvements towards the environment, making it go green. You have done
Thank
a
you,
lot of
sir.
work towards that. Excellent.
Thank you, sir.
I have two questions. One question is this: is this a complete unique project of this type? When you are benchmarked with other companies, is this a totally unique solution? A. B. You have somewhere mentioned your cost as for that transportation part. You have mentioned your cost as 0.4 lakhs, and the other robotic solution was 120 lakhs,
Yeah.
120 to 0.4. Now, while of
Right.
course, when you compare with the best of class 120, yes, that has its own plus and minus. We'll go ignore that. But there could have been other companies which might have used a non-robotic solution. And have you attempted to do any benchmarking in cost with respect to that? These were the two questions.
Okay, sir. Yeah, first question is about this project is unique. I would say that this project is like a benchmark kind of a process. Currently, is being used in all developed global foundries and few of the foundries even in India. But that is at the cost of around 20 crores, as I explained into the project, because this is the readily available solution from these three renowned OEM manufacturers like Loramendi, Hansberg, and Lampe. They are giving us the solution, and it has been readily adopted and put into the use by the foundry. Here our uniqueness is we have challenged that capex, and we have developed all those features, whatever purpose we wanted to solve into that project, without compromising on quality as well as other deliverables, and we got it manufactured from local manufacturer by adopting all these features
Okay.
from those offerings from the global providers. That is
That
the
was clear.
answer
Yeah.
of first question. Yeah. And for as far as second part is concerned, with that whatever that solution offered by these three OEMs, it is with only with these kind of robotics. We also tried many other options. Like first we thought of, okay, why can't we do with the manual and all? But looking at that kind of a number of cores and weight and all those things, like no, we can't do that. Then we thought of a cobot solution, but cobot has got certain limitations. It can't go beyond certain 10 kg and 12 kg, and that's speed and cycle time also was an issue. Another thing, we had a challenge ki Baba, we couldn't afford that robot, because that again that space required, because it requires its own space and safety and kind of a thing. So it is kind of a entire modular cell, and also we didn't afford that kind of liberty and that kind of premium price and all. So we did brainstorm, and we developed this solution of taking the core out, which is solving our purpose.
Okay. Thank you. Over to Dr. Ravichandran.
This is the answer.
It's a very good project, especially in Foundry, because nowadays nobody wants to work in the shop floor, and definitely not in Foundry. So
Thank you, sir. Yeah.
compliment you for coming to that side of the business. I have only one question. You have said cycle time is reduced from 17.8 minutes to 1.28 or 1.25. Can you explain how did
Yeah,
you?
2.8. No, this is cycle time 17 is put together, that there were 4 machines were placed into that cell earlier with this shell and other process, that we have switched over to that one single machine. Actually, it is not a cycle time of 17.8. So independent, if you see that bottleneck cycle time was around 9.9 minute was a bottleneck. So all put together, we just mentioned it is 17.8 cycle time for all 4 machine put together. But our takt time was like a 9.9 minute we consider for takt time.
No. What is takt time? Can you explain what is takt time?
Yeah,
So
9 point.
between tag time and your lead. Tag time is decided by the customer, not by you.
Yeah, that's
So what is your time?
that's
Your
okay with
time should be
customer
less than
demand.
the tag time. Otherwise, you will have a shortage to the customer.
No, that bottleneck machine cycle time was 9.9 minutes.
That is
What
not that
was
is
about
not
that
tag time.
bottleneck? Out of that 4
That
months.
is not tag time.
No, that
Mahindra
is not
cannot
tag time.
make such
That is
mistakes.
not tag time. Yeah.
You can't say
Yeah, I
that
agree.
because you have got a benchmark in this country. You cannot make fundamental knowledge mistakes. You can't call that as a tag time. Sorry.
No,
No, your
what I
company
mean
well.
to
I take
say,
liberty. I take liberty in bringing it to your attention because we bench many people are Mahindra. Mahindra cannot say. So you come back to me. What is your customer demand? What is the tag time? Tag time is based on nothing to do with the company.
Customer demand was very high.
What is the tag
And
time?
yeah, we were producing, sir, 4,500.
No,
And our
please
capacity.
don't beat on the bush. Answer my question. What is the tag time of the customer? And you had a bottleneck. You have done it very well. So I want to know now. Is it 10 minutes? It is 15 minutes. It is 4 minutes. What is? Okay, I leave you there.
Yeah,
Right.
that the
Really. Otherwise, you are getting
yeah that sir, requirement means we didn't had a liberty to produce as per the customer requirement, because this foundry is a captive
fair.
foundry and there were other suppliers also we wanted
Fair, absolutely
on
right.
that role.
Right.
So that
Second,
way
right.
we were given an opportunity to produce 4,600, and one supplier was strategically it was decided to close down because of its cost factor and delivery factor.
Right, that's
So
okay.
that
Don't worry.
6,500 we increased to 8,000.
No,
And
I
based on that
understand.
8,000, we decided the tag time, sir.
Okay.
Based on 8,000.
Right, your presentation was excellent, highly professional. I appreciate. Second point is a company of yours finally should tell us what is the cost benefit analysis, how much of time you have spent there, capex you have spent, revenue you have spent, hours you have spent, and you this benefited by reduction in manpower, reduction in rejection, reduction in lead time. So can you
Right.
not able to see the cost benefit? How much money you have spent for this in total?
Yeah, total approximate we have spent is a 2.8 crores. That is a capex. But I have also mentioned that life cycle cost, where we do consider that capex as well as opex also. So in that sheet, backup sheet, it is there. I mean, in presentation also it is flashing, where we have considered that whatever consumables we are putting, like raw material, consumables, and all that also we have put.
Yeah.
Based on that life cycle cost we have considered, because most of the times what we see, though capex is high, but life cycle cost becomes less.
So that comes under benefit. No, don't.
Yeah, so that way.
You have spent some money for capex. You have spent some money for revenue expenditure. You have shifted the more process. I've seen that. It was hit on the other side, right? So you have spent money there, and then a lot of people have worked. So a lot of money have gone into capex plus revenue. That is the cost. Benefit is reduction in energy, reduction in saving of sand. It doesn't go waste. So please do a cost benefit analysis.
So approximate I can say that 80% we spend on capex and 20% on opex, like some kind of a fabrication.
No, that I am not asking. You are not questioning my question. Suppose you spend 2 crores. Will I get back the 2 crores in 1 year, 2 years, 3 years, 10 years, 20 years?
Yeah, that is the payback we have calculated, which is less than 1 year.
That is important, such important project.
Yeah.
Because you are frugal, right? You are always Mahindra believes in.
In that presentation we have mentioned, sir, that payback is 0.75 years. Means whatever benefit we are getting and capex we have spent, which is 0.75.
But I am not able to relate that. Yes, I know that, but I am not able to relate. Okay. Over to you. Okay.
Thank you, Amar, for fielding all these questions. And Dr. Ravichandran's point was not about the payback of the incremental investment, but all the manpower, effort, and everything that you have put in. That kind of a study is what he is looking for. I'm sure you can look into it at some point of time, because that's important to understand, right? Is that clear?
Sure. Yeah, sure, sir.
Yeah. So I'd like to start with the statement that thank you for clarifying to Mr. Ramakrishnan that the conversion to cold box is not an original thought. A lot of people have
Right.
converted from shell core or hot box into cold box. So that is not the originality of this. The originality of this is, instead of buying from Loramendi or Lampe or whoever, you have
Yeah.
in
Yeah.
your own Foundry made it, which is, I think, quite unique. Am I right?
Right.
Yeah, because it's quite complicated. And
Yeah.
I see that you have eliminated, instead of the robot that Loramendi would have, you have put in a fixture which is much simpler, but does the job for you. Right?
Right, sir.
So those are
Right, sir.
very fascinating parts of your project, so which we all appreciate. Now, I have a question regarding the way you are treating quality in this project.
Yes. Yes.
So, yeah. So, first of all, I'm not putting too much into the sustainability angle of your project, because hot box to cold box or shell to cold box is not original. So,
Right.
of course, doing this is very good for sustainability, but it's something that foundries ought to be doing now. The question is
Right.
about, your project team has dealt with the quality aspects rather perfunctorily, if I may say so. For example, did you have a quality target? The only quality number that I saw is blowhole reduction. Yeah, blowhole
Right.
reduction is very useful, and especially since you're using cold box, the blowhole is bound to come down. But it's not only blowhole rejection, it's overall casting rejection. What were the core rejections, right? Other foundry rejections, and so on. But more importantly, you have to show these against the target. If I do this, my target of these rejections will be so much, and I achieved this. So I
Okay.
also don't see any statistical evaluation of the differences between the old situation and the current situation. So would you like to explain this as to why you haven't done all this, or you haven't shown this?
Basically, our focus was towards this payback and other parameters, sustainability. But definitely, cold box itself, inherent the quality is it will reduce the rejection percent compared with the shell, because the shell
Not
process itself has got
Not-
that.
Not necessarily core rejection or sand rejection. You can have as much sand rejection and core rejection with cold box. So
Yeah, assuming that process has been stable and process discipline is there, because foundry to foundry it varies. Yeah, I understand your point. Only I'm just comparing if my processes and discipline and my systems I'm running with this, and if I just compare that process change from shell to cold box, because the shell that resin percentages are 4 to 4.5% almost, and that phenol formaldehyde generation after metal pouring. That gas content is very high. It's around 20-22 gram per cc compared with the cold box. So that is one advantage we got.
Blowhole was supposed to go down and it has gone down. But the rest
Yes.
of it, you have to have targets and you have to explain what was
Yes.
achieved.
Yeah.
Because at this point from your project, we don't know if your quality became worse in the other respects or not.
No, rather that quality has improved. Our foundry rejection, we are benchmark in India because we are producing only block and head. So our current foundry rejection, including our customer end, is 6%, which was
Has
earlier 6.4%.
Has
So around
machining
all
rejection,
put together,
has
machining
machining
rejection is
come down?
it was 0.9%, which has reduced to 0.8%. That is machining rejection.
Okay. These things you should present, because
Okay.
without it, we don't know whether your project has really succeeded or not. We want to know that you have succeeded. We are always looking for such information.
Right. We'll definitely put. It's only related to that project I put that blowhole, but definitely I'll put that total rejection also will.
No, all of it is important, not only blowhole. Blowhole is automatic.
Yeah.
Right. Okay. Thank you very much. That's all we have, unless my colleagues have any other questions to ask. No, that's it. Thank you very much.
Thank you, sir. Thank you very much. Thank you.
Thank you very much. Thanks a lot.
Thanks a lot, sir. Thank you.